Hey guys, welcome back to the shop. Today we're going to be turning an old silver coin into an explosive. Alright guys, so this is not the kind of experiment I recommend following along at home. There are a lot of things that could hurt you. You know, a lot of corrosive acids you're dealing with, just generally nasty stuff. Of course you're making an explosive at the end, which is very hazardous, very dangerous. So I don't recommend trying this at home. If you do it at your own risk. You know, leave it up to me. Let me be the dummy. Let me be the dumb one to go out there and potentially, you know, knock a finger off. So we've moved outside here. You can see I got my bottle of concentrated nitric acid, 70%. And we are just going to add that to the beaker containing our silver quarter. Alright, so we're going to leave this to dissolve for a little bit. I'm just going to throw a watch glass over top of it. That's going to help recondense any nitric acid fumes that, you know, evaporate off. And it's also, more importantly, going to help prevent any impurities, such as, you know, this grass out here, anything from blowing in and creating impurities in our nitric acid solution there, which will soon become a solution of silver nitrate and copper nitrate. So the reaction was moving at basically a snail's pace at ambient temperature, so I threw it on the hot plate. And you can see now, things are progressing much faster. Quarter is dissolving. Alright, so we've got our solution of silver nitrate here, which is contaminated with some copper nitrate, which is why it has that blue color to it. And what we have here is a solution of sodium chloride, fully saturated. So, sea salt. And what we're going to do is precipitate the silver out of solution by adding it to this. So that milky precipitate you see there, that is silver chloride. And we'll know when to stop adding the sodium chloride solution, because it'll just begin dissolving into solution and no longer forming this precipitate. That is a thick mass of silver chloride. Now I kind of derped out earlier. I added way too much nitric acid and I didn't add enough water to fully dissolve the silver chloride that was being formed. So I kept trying to heat it for a while, but what ended up happening is I just had this solid at the bottom, which was my, I guess, silver chloride at that point. But all I had to do was add some water and everything just went right into solution. So I'm going to give this a minute to settle and then come back, add a little more salt solution to it and see if I have all of the silver chloride out of solution or if there's still some left in there. I'm pretty sure there's probably some more left in there at this point. So I added a little more sodium chloride solution. It didn't produce any more precipitate, so I know all the silver is out of solution. It's still a little milky, which is telling me that there's still some silver in the solution. But I'm just going to call that a loss because I'm not really going for efficiency here and decant off the liquid layer. Alright, going to give that a couple washes just to get rid of as much of the remaining copper as possible. Just going to add some water. Give it another rinse, get rid of as much of that copper chloride, or copper nitrate rather, as possible. Sure, I'm going to lose some more silver in the process. Try to break up some of the big clumps. So it's definitely still got a tiny hue of blue color to it. The camera probably can't pick that up. but there is still a little blue left. Alright, let that silver settle out for a minute, and then I'll decant that off and run it through a filter. And what we have here should be some very, very pure silver chloride. So at this point we've got the silver chloride in a little bit of water. And I'm going to add some potassium hydroxide. This will convert the silver chloride into silver oxide. See how it gets real dark? That's the silver oxide forming. You can actually hear the water boiling at the surface of the potassium hydroxide. Trying to break up any little clumps of silver chloride that I still see. Still a little bit of chloride in there. Cap off my potassium hydroxide. Stuff absorbs humidity from the air like crazy, very hygroscopic. Alright, we're left with a good bit of silver oxide, which we'll just throw in the crucible with a little bit of borax, and we should be left with a nice pure silver bead. Hopefully a bit bigger than a bead. So we've got our laboratory approved red solo cup filtration apparatus. And I am just going to dump the silver oxide muck right into it. Hopefully get as much out of there as possible. It was a near disaster. There we go. Slowly coming through. While I was waiting for the solo cup filter to do its thing, gravity filtration slow as hell, I neutralized the waste solution, which contained copper nitrate and definitely, or copper chloride rather at that point, and some silver chloride, definitely still quite a bit, with the potassium hydroxide, and you can see the black precipitate it formed. So I'll probably also melt this down into a bead, which will be mostly copper, so it might be like maybe 20% silver with the remainder being copper. Who knows, maybe more silver than that. I wasn't very careful with that decanting. Now that the majority of the water is out of the silver oxide and it's been washed a few times, I'm just going to remove it from the funnel here. Try not to rip. Try to push as much of the water out of it as possible. You can see it's staining the filter paper pretty well. Alright, so there is our silver oxide, ready to be converted into pure silver metal. Well, probably like 99.9 or something around there. New crucible. Some borax. Alright, so it looks like we have a nice little ball of silver. Maybe not quite a ball, but man, really need an acetylene torch. I'm going to try to tilt the cup and hit it again to try to get it all to coalesce into one ball. There we go. Beautiful ball of silver, finally. Focus. There we go. Nice ball of silver. Finally. I'm going to try to remove the bead. And it took some of the ceramic off with it. So I'm just going to hit that on the bench grinder real quick, get that ceramic out of there. Hopefully not introduce any metal impurities. Alright, just hit it on the bench grinder. Got rid of focus. Got rid of all the ceramic residue. And nice pure silver bead. At least, hopefully, very pure silver bead. Now we're going to dissolve this back in nitric acid to make a pure solution of silver nitrate. So now that we have our pellet of reasonably pure silver, I'm going to drop it into the test tube here and add a small amount of nitric acid to get some silver nitrate in solution. Going to try to use as little nitric acid as possible. Apply some light heat. That's reacting nicely, generating a good bit of nitrogen dioxide. So I'm just going to get this silver totally dissolved, and at that point we'll be ready to turn it into an explosive. So what I've done here is set up a gas generating apparatus. So we have a little pipette hooked up to some tubing. We got our nice flask here, bunch of water in it, definitely a huge excess of water. And what we're going to do is add some calcium carbide, small amount, to that water to generate acetylene gas. And then what we're going to do is bubble that acetylene gas through our solution of silver nitrate, and that'll generate something called silver acetylide, which is a pretty powerful explosive. So I'm going to add some water to our test tube there, because that's a pretty darn saturated solution of silver nitrate. Alright, so I'm just going to add a little bit of calcium carbide to this gas generator, and we should start seeing a white precipitate forming once all the air has been purged out of the system. Starting to see something happening. See, it's starting to look milky up at the top. That's our precipitate forming. The color of the solution actually indicates our silver purity was really good too, so that's pretty awesome. Alright, I think that's about as far as it's going to let us go. The limited setup I have here. Pull that out. So we're just going to filter this off, rinse as much of it out as possible, try to pull that big shard of glass out of there. I'm sure there's some little glass particles that we can't get rid of. But let's just filter that off and dry it out and check out the result. Alright, so I've got this set up for just simple gravity filtration, which is probably going to be a little bit slow. Just going to agitate this a little bit, pour it in. Give it a quick rinse out. So it looks like the product's already getting slightly discolored, probably from the fluorescent lighting I have in here. I'll save that to clean. So you can see there's probably some impurities of boron trioxide in there, most likely from the crucible. That's not going to be any kind of problem. And then there's a little piece of glass there that I need to pick out. So I'm just going to scoop this onto a watch glass now that we've filtered it and ran water through it a few times. I definitely see a little bit of glass actually in the product, but it shouldn't affect performance much. And I made significantly more than intended, which shouldn't be a huge problem, but definitely more than I wanted to make. I'm actually going to keep most of this wet, so you know what, let me transfer this, most of it back to, and I'll just store this in a brown vial under water so that there's never any chance of unintended detonation. But this I'm going to throw in the desiccator, let it dry for a few hours, and then we'll come back to it and test it out. So here we are a day later, and you can see the dry silver acetylide here. Focus. It's not gonna. There we go. Losing hope. Anyway, so we got the silver acetylide all dried out, and we're just going to do a little test here. You can actually see nice white color, which indicates our purity is very high. So let's take a little bit of this. Whoops, put my pucker goggles on. Take a small sample here, put it on the burn plate. I'm going to move the bulk of it away just so the shock doesn't set off the whole watch glass. And let's give this a test. Wow. My ears are ringing. Holy hell. That's some powerful stuff. Let's see what it'll actually do to the watch glass. Alright, so I've removed the bulk of the silver acetylide from the watch glass. There's still some staining, but I've got the big pile right there. Let's see if it'll shatter this watch glass. Wow. I cannot believe the watch glass withstood that. That's a testament to the borosilicate glass. That's impressive. I cannot hear out of my right ear. That is amazing. Well, I would definitely call that a successful endeavor. We were able to turn an old silver quarter into pure silver, then back into silver nitrate, bubble acetylene gas through it, convert it into silver acetylide, filter that off and dry it. And we have successfully made silver acetylide from an old silver quarter. And I think our purity is actually pretty astounding. I wasn't expecting it to be this good. But this white color here tells me that we're probably well over 99% purity with the refining of the silver. So Thank you so much for watching. I hope you guys really enjoyed the video. Please leave a thumbs up and consider subscribing. I have a lot more cool projects like this coming up on my channel, and we're going to do a lot of cool stuff.